This video is on graphical methods for quality control. This is the sixth in the R-Instat series on climatic analysis. The data are now tidy and defined as climatic. The data quality is now assessed through the dialogues in the Check Data menu. This video shows two dialogues, namely Display Daily and Box Plots. The data are time series and the Display Daily dialog shows the primary data that is to be analyzed. Some results are shown first. Then we show how to produce them. The first example shows data from Dodoma in Tanzania, where there are 4 elements: rainfall, sunshine hours, and temperatures. This is an overall look at about 100,000 data points, so detail is not apparent. But there is nothing here that gives great concern. Perhaps the more detailed examination may clarify something odd about T-marks around here. These data were from an NMS database and had therefore undergone various internal quality control checks. We still find the Check Data menu to be useful, and the work often takes just a few minutes. Omit at your peril, as you may well be dragged back to this stage later. In Lesotho, R-Instat was used by the Met Service at the data checking stage. The initial data from Mohotlong indicated that Timin and T-marks may have been entered wrongly for about 2 years in the 1970s. There were also some individual values that needed further investigation. The dialog is called Display Daily, but sometimes the initial data are at a different level. The dialog can be used as is shown here for a 10-day summary for maximum and minimum temperatures for 2 station data in Ghana. Again, the overall impression is positive except for the first row from the top of the figure below. We observe that for the first 15 years, temperature was higher than the rest of the years in the whole row as highlighted below. This shows that the data is potentially inhomogeneous, which needs to be checked further. The data from the R Open Air package are hourly and are shown here as a further example. Nothing stands out as a particular concern. Data from a station in Cameroon are used next. These were supplied in Excel and had not yet been checked. An initial look at the data gave some obvious concerns. The results show some temperatures of over 200 degrees. Also concerning is that the minimum of T-marks is 0. This is lower than anything in Timin, where the minimum was 5 degrees. Sometimes, missing values in Excel become zeros, which may have happened here. These data have been defined as climatic, so the Display Daily dialog can be used immediately. Include the 3 elements and press OK. Initially, this may be a bit demoralizing. However, with over 20,000 values entered, there is perhaps just one major typing error for every 1,000 values. That is why the quality control is needed. It is also why we recommend entering the data into a special system such as ClimSoft. Spreadsheets are very useful but are not designed for this volume of data entry. We look at the extreme values in more detail in later videos. But first, filter to check quickly on the values that are more than 100 degrees. Aha! There are 13 values where either Tmin or Tmax is more than 100. And in each case, it is 0.0. For example, 225.0. So probably these are all instances where they should be 22.5 instead. Make a note, so these are checked with the paper records and then corrected in the original data. We make this assumption here. With so few, we change them interactively. First, duplicate the variables to keep a copy of the original values. Values disappear as soon as they are less than 100, so you finish with an empty screen. Now get rid of the filter. The data are now plotted again. There remain some obvious errors. The next step with this data was to check carefully against the paper records. The second dialog uses box plots to examine the data. Start with data from 4 stations in Rwanda. The data are defined as climatic. Complete the dialog as shown. The individual points are the outliers in the data. These are data points for possible further examination. We first explain how they are calculated via the R-Plotly package. Here, you see the summaries as you hover over the box plot. This shows the lower quartile in September was 24.8 degrees. So, a quarter of the days had Tmax less than 24.8. The upper quartile was 28 degrees. The interquartile range was therefore 3.2 degrees. The usual box plot definition is that a temperature further than 1.5 times this value from the quartile is defined as an outlier. So, the lower fence is the smallest observation within 4.8 of 24.8 or 20 degrees. Here, there was an observation at exactly that value. The temperatures below that value are marked individually, down to the minimum value of 15.8 degrees. The high temperatures in September happen to go right to the upper fence value of 32.8 degrees, which is also the maximum. This coefficient of 1.5 is okay when there isn't much data. For these quality control activities, we often find a coefficient of 2.5 or 3 more appropriate. Return to the dialog. We change the coefficient to 2.5. Oh, and this graph was for all 4 stations together. Change the station option to show them separately. There are many options as we show. There remain a few values to investigate further. First, what of Tmin? This is very easy to do. This confirms the high quality of this data. It does pinpoint one very high value at Gisenyi. Maybe that 25 should have been 15. The ggplot system is very powerful. Could Tmin and Tmax be on the same graph? Return to the dialog, then plot options, and add a layer with Tmax. Make the coefficient 2.5 and see what happens. Interesting, but perhaps a bit confusing as a graph. We have now shown two of the key features of the graphic system in R and hence in R-Instat. The first is multiple facets, which has made it easy to examine the 4 stations. The second is multiple layers, which has facilitated looking at 2 elements on the same graph. Another option from this dialog is now shown. In the dialog, press Reset to start again. Then Teaming, but this time use the year and change the faceting to be by row. The result will show why. Also, tick on the variable width checkbox. Finally, change the coefficient back to 2.5 and the color again to blue. Each box plot is now a summary of 1 year, but about 365 values unless some data are missing. The box is now narrower in years where there are missing values. The graphs are displayed by row because there are so many years. Box plots show more features than just outliers. Here, Kamembe in 2016 and 2017 looks odd in that the box plot is a different shape to the other years. So, consider this station in more detail. Now, there are many box plots and each is a summary of a single month of data. There does seem to be more to be investigated in some months in those 2 years. Earlier, the Mohotlong data had a possible problem in 2 of the years. Here is the display daily graph again. Following the same steps as before, here is the yearly set of box plots for teaming. Then, adding Tmax does indicate that the 2 elements have probably been swapped during those years. The display daily and the box plot dialogues complement each other. Display daily shows the whole time series. The box plots usually show the main components separately. This can be the time component as here, or it may be the seasonal component. There seem to be lots of outliers with the seasonal display, but that's largely because of the mix-up in those 2 years. This is our first climatic video on graphics. In R, the ggplot graphic system is extremely powerful. Here, GG is not slang for a horse, but signifies the grammar of graphics. It is useful to distinguish between exploratory and presentation graphs. Exploratory graphs are designed for the analyst. In this video, they are all exploratory. They should be quick to produce and help with the data examination. Presentation graphs are for reports and presentations. They usually take longer to produce and are designed for others to see the results of your work. In R-Instat, if the graphs you need are not in the climatic menu, they use the Describe menu. Once in a dialog, the Plot Options button gives access to a rich set of possibilities to present the graph as needed. This concludes our initial look at 2 of the dialogues designed to help in checking the data. The next videos consider quality control in more detail.